Okay, my camera was acting a little weird there. Let's move on to the next time scale, which is the deglacial time scale. Here we invoke the solar radiation changes associated with the various orbital parameters as proposed or as derived by Milutin Milankovitch. So we are looking at the last 20,000 years where the last ice age ended and brought us to this present situation with us evolving as modern human beings with agricultural lifestyle moving into industrial revolution. So you can see the carbon dioxide coming out of the glacial maximum was around 200 because during glaciation it drops by about 80 to 100 ppm. The pre-industrial levels of 280 ppm were reached by around 9,000 years ago. Slow deglaciations happened, all the glaciers disappeared, and then the CO2 remained fairly constant till the Industrial Revolution and the large-scale coal burning. Of course, Bill Ruddiman, from whose book these figures come from, argues that actually carbon dioxide began to increase in the atmosphere from the beginning of the Holocene itself, around 10,000 years ago, because human beings started to deforest and convert large tracts of land to agriculture. Okay, so we can say that there was a slight increase from end of glaciation to the beginning of industrial revolution, and then we have accelerated the increase, of course, by now. If we look at the solar radiation winter and summer months, along with the ice volume shown here as percentage of the maximum size. So if you took the end of the last glacial maximum as 100%, then the ice sheets began to disappear and they reached the current configuration with Antarctica and Greenland and the mountains around 6,000 years ago. Okay, you can see the relations between CO2 and ice volume again. And there is the radiation forcing in the summer, which peaked in the period of around 9,000 years, and we will see that there is some evidence of that forcing on changes in vegetation and so on. And the winter radiation reached its minimum around 10,000 years ago, just a little bit before the summer maximum. And we have been in this decreasing cycle, so the winters are warmer in that sense. So this is a deviation from the current top of the atmosphere radiation, and that's the summer and winters at present. So we take the current times as the baseline. We were colder in the winter before and we were warmer in the summer before. Okay, that's the deglacial time scale. There have been reconstructions like this one called CliMap, which looked at the changes in sea surface temperature. So this is the August ocean temperature estimated for 21,000 years ago, when we were still deep in the glaciation and the glaciation had reached its maximum. You can see the ice sheets down here into deep into the US, in fact down to New York, because Long Island, which is an island off of Manhattan, is a so-called terminal moraine. The glaciers, as they grow, they push stuff in front of them, the rocks, the vegetation, all the debris and so on, and they deposit that where the glacier terminates and then begins to retreat. So this Long Island is in fact created by the debris that's pushed by this ice sheet, which is referred to as the Laurentide ice sheet. You can see glaciation of Iceland, Greenland, and deep into Europe as well. Corresponding to that, there were changes. So this is the August temperature change with respect to modern temperatures. Much colder temperatures here in the North Atlantic, which tends to be the center of action through the Atlantic meridional overturning and so on. You can see the temperature changes here. Remember the heat balance we talked about with heat uptake in the deep tropics in the Pacific dominantly, and the heat loss at the Kuroshio and the Gulf Stream. So you can try to find correspondence to those, because the ice sheets here would have modified those heat fluxes and the currents and so on and so forth. So subtropical gyres appear very warm. There are uncertainties in these reconstructions. They have been debated and so on, but it gives you a good sense that the last glacial maximum had extensive changes imposed on the ocean temperatures, which means atmospheric temperatures were also different. ITCZ would have been different because the glaciers coming down so deep into mid-latitudes, and of course the winter sea ice again reconstructed based on various paleo proxies like Delta O18, benthic forams and other things. The modern sea ice extent is shown here, and the winter sea ice extent during the glacial maximum would have been obviously much larger because the entire planet would have been much colder. There are evidences buried in vegetation and so on in the Andes during the last glaciation. The glaciers on this mountain came down by 600 to a kilometer compared to where we are today. The glaciers retreated during the Holocene after the end of the last glacial maximum around 18,000 years ago to 12,000 years ago, but some glaciers remained all the way down to 6,000 years ago. Right? So the vegetation has since been replaced further up by grasslands, which you can see here as well. This depends on soil type, soil moisture, temperatures, etc. So those are the extent. So the retreat of the North American ice sheets is shown here. So the ice disappeared almost completely here around 6,000 years ago. So 14 to 18,000 years ago we were down here, and the Long Island is subsumed here around 14,000 years ago. And all these Great Lakes that exist now were basically carved out by the glacier, and then they were filled by the glacial melt as the glaciers retreated from 18,000 years ago, 14, 12, 10, 9, and so on down to 6 all the way here. Obviously Greenland still remains glaciated, but its extent was much larger during the last glacial maximum. So long story short, the ice ages in the 100,000 year cycle we are in the last 1.2 million years or so fits this glaciation of the last ice age that ended very recently, and we will look at how things have changed since. Okay, that brings us to into the historical climate change, but we have one other time scale to look at. Glacial, deglacial is 100,000. There are much shorter time scale variations in data records that are called millennial oscillations. Very strong evidence that they existed all across the globe, but no solid theory as to what could have caused them. Right? We understand tectonic timescale changes, orbital timescale changes, glacial, deglacial timescales, and then the uncertainties still remain into modern changes as well. Okay, we'll see that.